If you were going to look for nickel laterites in the Tasmanides, where would you go? What depths of cover would you be willing to accept in order to explore for prospective targets? The early stages of exploration involve a judgment between which prospects are worth follow-up detailed analysis and which need to be left to the side. And there are a range of information sources that we can use to make these judgments, whether it's simple heuristics, mineral potential studies, following the fertile bands of minerals provinces as they extend undercover, or what was the phrasing? The fancy interpretations of geophysics. The toolkit that I'm going to talk to you today is something that we've been developing in collaboration with Monash University. It's not designed to answer these questions, but it's designed to provide another perspective, to define the economic fairways for exploration. And in order to demonstrate this concept, I'm going to present a case study for looking at the economic fairways for exploring for nickel laterite deposits in the Tasmanides. Now, we've had a few disclaimers over the course of the meeting. Here's a public service style one in the context of the upcoming federal election. I am apolitical, so we'll leave it at that. So first of all, let's define our question here for the case study. So, laterites 101. Laterites can be defined as part of a broad suite of superficial mineral systems. There's a genetic relationship to the mafic, ultramafic mineral systems. In this case, there's a supergene enrichment through the development of a weathering profile where nickel is enriched towards the base of that weathering profile. And we end up with a relatively thin tabular ore body geometry where the metal content, the grades are enriched relative to the original protolith. And that enrichment process can also enrich other elements as well, notably cobalt. The association of cobalt with nickel mineralisation has long been recognised. But an analysis of the geochemistry of Australian ore deposits quantifies the strength of this relationship. It shows that for nickel laterite deposits, the relative cobalt enrichment can be twice that for komatiite-hosted nickel sulfides. Actually, from the perspective of cobalt, as we can see on the x-axis, laterite nickel deposits may represent a richer source of endowment. So there's a critical minerals aspect to this. As we have an increasing focus on battery metals like nickel and cobalt, I suppose the question here is do these deposits represent an opportunity for opening up the value chain for the supply of cobalt? In order to answer that with respect to the Tasmanides, we need to then think a little bit about the deposits in the Tasmanides. So first of all, the most recent publication of Australia's identified mineral resources puts the economically demonstrated resource base of nickel in Australia at 21.2 million tonnes, which ranks Australia first globally. That's about 22% of the known global resources. Production, which is shown by a slightly thicker outline on the symbols, is really dominated by those traditional magmatic sulfide deposits, and notably mainly occurring in Western Australia in the Yilgarn. We can see the size of the deposits there. Australia ranks 5th globally for the production of nickel. But if we look at the Tasmanides, they're really characterised by a series of much smaller nickel laterite deposits. So I suppose there's a question about, what is the opportunity that is presented by the nickel laterites that we see in Eastern Australia? How does the relative enrichment of cobalt play into assessing the opportunities for these deposits? And how are they placed given their relative location near the major infrastructure along the east coast? So to answer these questions, we're adopting the economic fairways approach. As I said, we've been developing this over probably about 5 or so years now in collaboration with Monash University. Economic fairways is designed to bring together and integrate large-scale geological and infrastructure data sets to evaluate the mining, processing, administrative and infrastructure costs for resource development operations across Australia. And so you can see some of these represented graphically. I think it's important to stress here that we're not saying anything about the technical, the geological potential for discovery, but we do incorporate geological information to the extent that it informs our economic calculations. So if we know that we're looking for a basement-hosted resources, then we can use the national maps of estimated sedimentary thickness to estimate the depths of that we would need to drill through in order to access these resources. And the concept here, I guess to explain this, we need to reflect a little bit on a very generalised exploration framework. So you can see as we step through this framework, we're essentially moving down through a scale reduction process, starting out with the grand, I suppose, mineral systems, conceptual frameworks, moving through into mineral provinces, down to the sorts of scales that we've seen discussed in a lot of detail over the last day and a half, through to deposit identification. And it's only once we get to this point, traditionally, that we start to bring on board in-depth financial considerations in the forms of feasibility studies. So the intent behind the economic fairways approach is to move financial considerations to sit much earlier in the process, to sit alongside the traditional considerations of geological potential. And I need to stress, we're not trying to replace feasibility studies here. You still need to do due diligence. There's a real difference in the intent of the scope and the questions that we're trying to ask here. It's about trying to define, what is the geological potential, but within the constraints of economic feasibility. So that sort of talks about what we're trying to achieve, and then I suppose the other aspect of this is how do we go about doing this. Now this is an incredibly messy slide. I'm not intending for everyone to go through the details or to talk through that in great depth, as much to say that we can take advantage of the interrelationship between the different system components when we're looking at a mining or a resource development operation. From our mineral systems understanding, we can build ideas of ore body geometries, and understanding their depths and dip can allow us to evaluate the most appropriate methods for mining, which informs project startup and the lifetime of the mine, and that informs our understanding of the run of mine, the mining capacity. It flows on into our understanding of the processing capacity, which then tells us about the sorts of infrastructure requirements you might need in terms of the amount of energy you need to power these operations, the distances you need to travel in order to move a certain amount of material to port. And these all inform our understanding of the capital and the operational expenditure requirements for resource development projects. All of these factors can be brought together and integrated into a single consistent model to estimate sort of first order high level estimates of resource economic viability. Now the codes to do this, it's all made freely available through Geoscience Australia's GitHub account under the software repository named BlueCap. It's a series of Python software libraries. Now we recognise that if you want to go into the codes and play around with the assumptions and pose really specific questions, you can do that. But there's a real technical hurdle to being able to access that. So we also make the economic fairways approach available through the Economic Fairways Mapper, a tool that's on Geoscience Australia's portal, which you can navigate to through the tools option on the top right-hand side of the ribbon. It's designed to work in the browser. You can use it on your mobile phone, which is not to say that you should stop listening to what I'm saying now and test it out, but each to their own. So to bring this to bear to the specific case study that I've been talking about, there are a range of different input assumptions that we need to put into this modelling. And these are sort of tabulated here. I was putting this example together sort of in the late stage of last year. I was a little bit concerned that the prices that I was putting in there for nickel and cobalt were a bit optimistic. They're sort of, when you look at the past 5 years, they're relatively high. And well, this year has been quite the ride. I think nickel at the moment is trading at about $30,000 a tonne, and cobalt at about 80,000. So there is, there's a fair bit of variability there, and I think it stresses that when you're forecasting long-term prices over the length of a mining operation, there's a lot of uncertainty. So bear that in mind. The grades for the different metals are based again on the median values that we might expect to see from the geochemistry of ores database that I presented earlier with respect to nickel laterites in the Tasmanides. Ore body geometry, again tabular, following our understanding of the mineral system. There's a few financial considerations, and then just to say that we've used the sedimentary thickness geoagnostics model, the AusSeaBase 2021, the most recent publication of that, and added an additional 10 metres of cover just to replicate that sort of upper barren section of the weathering profile. And before I get into the results, I also wanted to, I guess, just stress that the absolute values that we're getting out of this are going to be highly dependent on the input sort of cost functions and different assumptions. So here I'm just showing an example of the data that's available to calibrate these sorts of cost functions. So for this example, we have a bulk cost function that's defined by the production of nickel commodities. It would be nice to be able to go into much more nuance and more granularity to talk about specific mineral systems. For instance, you might think that given the higher clay and silicate contents of laterite, that there would be larger beneficiation or hydrometallurgical costs involved in processing those sorts of operations. And I think if we look at the data, you can sort of see the hints of that playing out. But that's also to some extent a function of the limited amount of data that we have available to calibrate these. And certainly, when it comes to individual operations, there's a lot about the individual characteristics of a deposit that are going to define these things. And you can see that between the sulfides and the laterites, particularly at low capacities, which is probably what we're talking about in this scenario, those mineral systems differences are within noise. So there's a range of different results that we can get out of these styles of processing. On the left-hand side, again, just showing the depth of sedimentary thickness for reference. And then we go through a series of different results. We've got the net present value, the average annual employment, the sum of the corporate tax and royalties, and the break-even grade. I'll talk a little bit more in depth about the net present value and the break-even grade in more detail. There are also a couple other things that I haven't shown here. We can run analysis into things like sensitivity analysis, uncertainty analysis. We can do things like adding infrastructure to the map of Australia and seeing how that changes the economics of resource development. So here's just a brief overview of some of the results that we get for net present value. So that's really the sum of future cash flows over the projected project, inflated into the future and then discounted according to the user input discount rate. There's a few different models I'm showing here. The one in the centre is really the default scenario that I've sort of presented based on the assumptions in the earlier table. On the left-hand side, we can see the results from just not including any cobalt whatsoever. And the one on the right-hand side, I sort of put in at the last minute. I was just interested to see, if we took the present-day prices at face value and ran it, what impact does that have? Not necessarily suggesting that that's a sensible thing to do, and I certainly don't have the experience to forecast prices into the future. I think on one hand, you've got strong demand for battery metals, and on the other hand, as those prices go up, you're certainly going to increase supply, which has a negative feedback loop and dampens prices. What can we see in these different results? Well, first of all, I think intuitively you see the real first order importance of the depth of cover. That's really controlling the projected viability of nickel laterite projects. The second order features probably a little bit difficult to see. It relates to the distance to power infrastructure. And it sort of shows up in far north Queensland where you're moving away from the existing national electricity market and you have to essentially supply your own energy costs with a big step change in the costs of a project. But once we really restrict things to those areas of relative outcropping of the crystalline basement, within that scope, the first order control really comes back to distance to transportation infrastructure, and I'll show that in a moment. And I think what we can see in these results as well is, I suppose, the opportunities that are being presented by this mineral system across the Tasmanides. Without cobalt, these sorts of mineral deposits are really somewhat marginal. The additional value that we're seeing for cobalt is making these look a lot more attractive. And I should probably also stress that, again, there's a lot of uncertainty in the overall estimated values. If you think that these results are rubber stamping particular projects, then I think there's certainly a lot more work to do, and you'd be looking at detailed feasibility studies for that. But what these results are provide a much better constraint for, I feel, is the relative change in the economics between different locations. So we can see a sort of an example of that here as we've zoomed into the area around New South Wales and Victoria and changed the colour stretch. And it really quantifies the interrelationship between these different components of the resource development system. We can see the importance of the transportation networks. Within this area, just the proximity to major roads can change the estimated net present value on the order of sort of $40 to $60 million. So it's another perspective that we can take to judge the relative merit of looking at different prospects in the early stages of exploration. Another metric, or another way of looking at the results that we're getting out of this is through break-even grade analysis. Now, in this case, we're modelling a nickel equivalent. Break-even grade gets a little bit complex when you're dealing with multiple metals in a deposit, and trying to reflect on, I suppose, what that means. But in this case, our processing has assumed the production of a nickel concentrate, and that the cobalt is being produced within that nickel concentrate too. So there is a net smelter penalty that's applied to the value that you would otherwise expect for that cobalt, in this case of about 50%. But nevertheless, given the prices that we've assumed in this particular case study, the cobalt's still contributing probably about a factor of, I think it was about 1.75 relative to its grade to equivalent nickel. And we can see that within those areas of outcrop, the break-even grade for nickel is estimated at about 0.6, which is coming in at about the grade we're expecting for nickel based on a median-style Tasmanides nickel laterite. So I think that's in some sense an important perspective to take on this, because if you're going out looking for with a nickel laterite exploration model, looking at the projected economics for median values sort of allows us to tease out, if we discover something that is on average what everyone else has discovered, where does that leave us? How do we stand? Obviously, we'd all like to find the big deposits, but in some sense, their economics is always going to look good, and the results aren't nearly as interesting and don't give us as much nuance and able to be able to tease out these different interrelationships between the system components. If again we zoom into that area in New South Wales and Victoria, and again play around with the colour stretch, you can sort of see this the impact that this is having on I suppose the grades that you would need to target in order to try and produce an economically viable model. In this case, instead of looking at net present value, what we're seeing is that the proximity to the transportation infrastructure is changing the overall nickel equivalent grade by an order of about 0.1%, from about 0.6% on the roads, moving out to 0.7 nickel equivalent in remote areas. So I suppose there's a few things I wanted to summarise in reflecting on this particular case study. First of all, the specifics about the opportunities around the Tasmanides. As I've stressed in this talk, the uncertainties on the absolute values that we're getting out from this process are large. To the extent that is possible, they've been calibrated to Australian conditions, based on industry data. But I think what is really key is looking at those spatial relationships and how those could inform the early stages of exploration. We're seeing that the additional value that could be realised through the renewed focus on cobalt is really supporting, or at least encouraging, renewed interest in nickel laterite deposits, even at the scale of typical deposits for the Tasmanides. If you're looking at evaluating different potential prospects, then the transportation network really is key. If higher prices could be sustained, then that's really starting to take the pressure off that depth of cover assumption. And in that sort of context, I think that sort of really underlines the importance of regional projects that are helping to map the depth of cover across these regions, because that's ultimately the first order control of cost for these sorts of projects. But there's also, I guess, some reflections that we can make about the economic fairways approach as a more general toolkit. I think what this has shown is that this approach allows us, in particular, to undertake sort of rapid scenario testing. We can quite easily pose different questions and run different scenarios, compare and contrast, in order to dig out some of those nuances about different aspects of understanding the opportunity for exploration and development of different mineral systems. I've shown an example for nickel laterites and the associated byproduction of cobalt, but the blue cap and the economic fairways mapper have also been calibrated to handle other commodities such as copper, lead, zinc, potash, phosphate, and some other associated critical commodities such as the platinum group elements and the rare earth elements. As I mentioned, to the extent possible, this is calibrated to Australian conditions. I think that's really key. It allows us to peg the results that we're seeing to actual industry conditions. Uncertainties are large, and for our cost functions, they've had to be calibrated to bulk commodity cost functions. We're not able to go into the nuance currently of different mineral systems. But I think it's important to have that ability to peg these computations to actual data. And finally, in terms of summing up the conclusions, the economic fairways approach really provides an integrated toolkit to help inform decision-making in the early stages of exploration. And I just wanted to finish by, again, showing the URLs where you can access these sorts of resources. I think this project is really at a stage of maturity where what we really need is much more feedback from industry. So if this talk is of interest to you and you have a spare moment, I'd be keen to hear how, if you're able to test out the tools, then I'm keen to hear your feedback. What you like. If you have any questions about the underlying assumptions or methodologies, please get in touch. I'd love to hear it. Thank you.